After high-temperature melting, they turn into massive aluminum ingots. The aluminum ingots are then heated to 500 degrees Celsius. They are continuously hot-rolled forward along the rollers. Eventually, they become gigantic aluminum rolls. This is the process of aluminum recycling and remanufacturing. To create a multi-ton aluminum product, the first step is to collect aluminum cans from scrap yards. It's worth noting that these cans contain over 90% aluminum. Using aluminum cans for smelting is a perfect choice. Although it may not seem like much, these cans add up to millions in total. The first step in the process is impurity removal, where machines use vibrations to break down the waste. Iron cans hidden inside are attracted by magnets above. Pure aluminum cans drop into storage bins. Giant robotic arms then slowly transport them forward. The factory's massive scale is impressive. Even a single conveyor belt is designed to reach tens of meters high. This is to deliver the cans to the electric furnace ahead. Inside the furnace, the aluminum cans are initially heated. This process removes surface paint. Here's why removing the paint is essential. During melting, the paint produces substances that can alter the aluminum's physical properties. The aluminum becomes looser as a result. Failing to remove the paint can change the hardness of the aluminum structure. In no time, the molten aluminum reaches 700 degrees Celsius, ready for casting. It starts flowing downward in large batches. Below lies a massive mold about 5 meters deep. Once the surface equipment is removed, you can see just how enormous the underground pit is. Surprisingly, the edges of the aluminum ingots are also so precise. The difference between a large factory and a small workshop is striking. Although the surface of the aluminum ingot has an uneven layer, this won't affect the cold-rolled final product. Before hot rolling, the surface of the aluminum ingot is polished. Now, let's take a look at this massive aluminum ingot. From its appearance, it's taller than an average adult man by a significant amount. And in terms of weight, this thing must weigh several tons. I tried to look it up but couldn't find exact figures. So let's estimate it at around 2 tons. It's pure white and uniformly colored, making this aluminum ingot top-quality material. With the aluminum ingot now formed, it moves to the hot rolling stage. Before hot rolling, the metal is heated to 500 degrees Celsius. Since aluminum's melting point is 660 degrees Celsius, the temperature stays below the melting threshold. The aluminum piece is then placed in a rolling machine. Through external force, the metal's thickness is reduced. Each time it's rolled, the aluminum becomes thinner. This continues until it reaches the required thickness. During rolling, the front and rear ends of the metal deform. The irregular parts are then cut away. The discarded metal isn't wasted. It's melted down in the furnace for future casting. After multiple rounds of rolling, the aluminum piece becomes thinner. At this point, the aluminum is coiled around the inner shaft. It looks perfectly neat, with no sign of misalignment. In no time, an aluminum roll is complete. Compared to steel rolls, aluminum roll processing seems easier. It simply involves repeated rolling. Then the cold rolling process is completed. As it progresses, the next round of high-precision cold rolling begins. The previous cold rolling step can be seen as a preheating stage. This step here is where the final product is truly processed. The thickness of the aluminum plate is further reduced to a specific level. In just a moment, one roll of aluminum is fully processed. Did you know? Just one roll of aluminum can produce 750,000 cans of soda. These then make their way into countless households. Next, let's see how aluminum cans are produced. First, the aluminum roll is fixed to one end of a conveyor. One side of the aluminum plate is placed on a stamping machine. The machine stamps at a speed of 2 cans per second. This process is entirely automated. No manual labor is required at all. In no time, the can bodies are stamped out rapidly like raindrops. Driven by machines, they are swiftly transported forward. Each can body is then inspected one by one. However, I'm curious. With so many cans, how does the machine detect defects? At this point, the can body production is complete. Next, it's time to make the next key component. Now we move on to producing the can lids. The raw material is also aluminum. However, this machine operates like lightning. It stamps at least 4 can lids per second. At this speed and efficiency, it undoubtedly meets national carbon neutrality standards. This thin piece of metal looks small, but do you know what it's used for? This thin strip of metal is used to make can pull tabs, the handles on cans that allow you to open them. Once the pull tabs are stamped, they are attached to the can lids and secured. When all the can lids are completed, The next step is packaging. This step also relies on automated systems. Every stage is completed by machines. It's no wonder why the mechanical systems in Japan and Korea are so advanced. In societies with declining birth rates, fully automating machinery is undoubtedly the right choice. Otherwise, with fewer people, there might not be anyone to tighten screws in the future. And that concludes the entire process of aluminum recycling.